Hello and welcome to my channel. In this video we are going to solve an example from complex numbers chapter which had appeared in JEE Main 2016 paper. A value of theta for which 2 plus 3i sin theta over 1 minus 2i sin theta is purely imaginary is. So here we can see that there are four options given. So before we begin, let us understand what are complex numbers. Complex numbers are denoted by the letter Z, and we write the complex number Z as a plus I times b, where a represents all the real numbers and ib represents all the imaginary numbers. So a complex number is a combination of a real number and an imaginary number. So here we can see that the given expression has real terms as well as imaginary terms as well. So in total this represents a complex number. So let us denote this given expression as Z. Now let us begin to solve this expression. For that we are going to use the rationalization method, where we are going to multiply the numerator and denominator by the conjugate of the denominator. So here you can see that I have written the same expression which was given in the question, and I have multiplied the numerator and the denominator with the complex conjugate of the denominator. Now in the complex conjugate, the negative I term turns to positive I terms, and if here it was positive, we were going to negate it. So conjugate means the opposite of the imaginary terms. So here the real number stays the same, as we can see 1 stays 1, but negative 2i sin theta, its sign changes to positive 2i sin theta. The same thing we are going to put it in the denominator, that is 1 plus 2i sin theta. Now this is called rationalization of the given term by its conjugate. Now let us begin by multiplying the numerators. So here we are going to use the FOIL method, that is 2 multiplies with 1, giving us 2 times 1, plus 2 multiplies with 2i sin theta, which is written over here, plus 3i sin theta multiplies with 1, which gives us the third term, 3i sin theta, and the last term is 3i sin theta multiplies with 2i sin theta. Now for the denominator we can see that it is of the form a minus b, a plus b. So a minus b times a plus b is an algebraic expression which becomes a square minus b square. So using this algebraic identity we can write the denominator as, considering a as 1, so we get 1 square, minus considering b as 2i sin theta, we get 2i sin theta the whole square, that is a square minus b square. Now let us simplify this term. So we have in the numerator 2 times 1 gives us 2, plus 2 times 2 gives us 4, so 4 times I times sin theta, plus 3i sin theta, plus 3 times 2 gives us 6, so we are multiplying the numbers first, then I times I gives us I square, times sin theta gives us sin square theta. Now in the denominator we have 1 square is 1, minus, now this entire term gets squared, that is 2 squared is 4, and I squared we have written as I squared here, and sin theta square is written as sin square theta. Now let us further simplify this. That is, here we can see that 4i sin theta and 3i sin theta are like terms. So we can simply add them up and write it as 2 plus 4i plus 3i is 7i sin theta, plus 6 times I square value is negative 1. So we have replaced I square by negative 1, times sin square theta, over 1 minus 4 stays the same, and I square we know that its value is negative 1, times sin square theta. Now further simplifying this, we get 2 plus 7i sin theta, plus times minus is minus 6 sin square theta, over, in the denominator we have 1, minus of minus is plus 4 times sin square theta. Now for the next step, let us bring the real terms together and separate out the imaginary terms. So here we have written 2 minus 6 sin square theta. Now these two are real terms because they do not have an I term in that is imaginary term, plus 7i sin theta. Now this is separated because this is an imaginary number. Now the denominator stays the same. Now I am going to split the terms for the real numbers and the imaginary numbers with the denominators. That is 2 minus 6 sin square theta over 1 plus 4 sin square theta, plus 7i sin theta over 1 plus 4 sin square theta. So the denominator is split for real terms as well as imaginary terms. Now after we have done this, let us come back to the question. Here they have given that a value of theta for which the given expression is purely imaginary. So if the expression has to be purely imaginary, then the real term has to be 0. So here we have separated out the real terms. So I have written here, this is the real part of z and this is the imaginary part of z because it has an I term. So here the real term should go down to 0 because we want only the imaginary part. So now let us make this expression, that is real terms going down to 0, which is, so real part of z is 0. So 2 minus 6 sine square theta over 1 plus 4 sine square theta is equal to 0. Now taking the denominator on the other side of equal to sign, this denominator multiplies with 0, so it goes down to 0. So we are left with only the numerator, which is 2 minus 6 sine square theta is equal to 0. Now once we have got this, we can take this minus 6 sine square theta on the other side of equal to sign. So this expression becomes 6 sine square theta minus becomes positive when we send on the other side of equal to sign. So 6 sine square theta equal to 2. Now taking 6 on the other side of equal to sign, we get sine square theta is equal to 2 over 6, which can also be simplified as 1 over 3 because 2 and 6 go in the table of 2. Now sending the square on the other side of equal to sign, it turns into a square root. So we have here sine theta is equal to plus or minus square root of 1 over 3, or we know that square root of 1 is 1 itself. So we can just write it as plus or minus 1 over square root of 3. Now since the question asks us to find out the value of theta, we are going to take the sign on the other side of equal to. So we get here theta is equal to sine inverse of plus or minus 1 over square root of 3. So here the value of theta could be sine inverse of 1 over square root of 3 or sine inverse minus 1 over square root of 3. So let us come back to the options and see if this is one of the answers. So here we have option D, that is sine inverse of positive 1 over square root of 3. So D is our answer. I hope you have understood all the steps and liked the video. If you found this video useful, then you can click on this playlist which covers more questions on competitive exam questions. And if you're liking my videos, like, share and subscribe to my channel, and thank you for watching.